Hello everyone, welcome back to another video. Let's solve today's daily problem. Okay, here we go. Hmm, see, we have an integer array norms. Okay, then we have an integer array norms and two integers k and the number of operations. Okay, you must perform an operation. Okay, in each operation, select an index, add an integer, add any integer in the range minus k to k. Okay, this is fine. So it's a hash map problem, I think. Um, let's look at this. K is 1. So the answer is 2 because we can subtract this by 1. Hmm. Well, the first thing that comes to my mind is binary search. So first we can hash the frequencies and then the max will be okay. So this is my intuition so far. Okay. Let me just increase this. Give me a second. Okay. Um, I think I messed up. Okay. Okay, so let's say we have let me get this. Okay, so let's say we have 5, 11, 20, and 20, right? So okay, so 5, 5, 11, 20, and another 20, right? So our k is 5. Now we're gonna for every number from the minimum, which is 5, to the maximum, which is 20, we have to check how many of those can we make after performing these many operations, right? Okay. How do we do this? I think I'll jump into the code because I have a rough idea about how to solve this. So first, let's get the length of the numbers. So L and R are the binary search base values, which is the minimum of nums and the maximum of nums. Let our hash map be the counter, which is the frequency, right? And now what do we do? Okay, so if result is equal to initially 0, hmm, what are the constraints? 10 power 5, right? Okay, so for while L is lesser than R, our mid value is going to be L plus R divided by 2. Okay, so if the mid, if let's say we declare, we're going to define a check function which is going to say if check of mid is valid, then let our minimum element, we need to maximize it, right? We need to maximize the frequency. Return the maximum frequency of any element. Okay, so if check of mid, okay, let's say our hmm, these can be any numbers, right? So nums is also any number, okay. Okay, I have a rough idea. For every number, I don't think we need this. Start so. Okay. For every number, so 5, 11. Okay, so 5, 11, 20, and 20. And our k is equal to 5. Let's say k is equal to 10, just for the sake of this example. Now, for every number, check the leftmost limit index and the rightmost limit. Okay. Then you just do L minus R, uh, R minus L, right? So we get 10, 1, 2, 3, 4, 2, 3. That is fine. Let's say we have k is equal to 0. So we have 11, which is right there. Hmm. Okay, so I need the rightmost and the leftmost numbers, right? Okay, so nums, then okay. Okay, that is fine. What about this test case? How do I do it for say 5, 2, 4, 1, k is equal to 2. Answer is equal to 4. Wait, it might not be binary search actually. Maybe I was wrong. Okay, how about think about it like this, a sliding window problem wherein a sliding window problem where the window is of the size 2k. Now I think that's it. That is how we solve it. And I was beating around the bush until now. So yeah, I think that's it. Yeah. So a window is equal to window size, let's say, is equal to 2 times k. Okay. And we don't need that either. Comma r is equal to 0, comma l is equal to 0 for I. Okay. So while what is the current difference, right? So current is equal to nums of r minus initially. So yeah, the difference between the right and the left number equal to nums of r minus nums of l, right? So while diff that is equal to that, what would we say? While that is greater than size L plus equal to 1, result is equal to max of result, comma, R minus L plus 1. It seems fine. Then return result. Right, the number of operations as well. Okay. And we also need the minimum, right? So result, comma, number of operations. That is also there. Forgot about that. What is the acceptance rate of this? 34%. Wait, let me think about this. This is not gonna work because of the num operations. Okay. So we do need binary search, I think. Okay, which number to choose? What's the value of k here? K is also 10. Wait, is this? Can we pass this into another function? Okay, how about this? For 1 to 10 power 5, okay, that actually works. That, yeah, that actually works. My initial thought process was right. So L comma R nums for n range L comma R small. If L lesser than 0 or nums of L lesser than n minus k, L plus equal to. If R is greater than n minus 1 or nums of R is greater than this k, is it, so result is equal to, but how are we doing the operations here, number of ops? So needed ops is equal to so okay, initially res is equal to 0, and now it should be fine, I think. Yeah, I don't think this will exceed the time limit. So let's try submitting it. Where's the sub? Perfect. Yeah, so that was the solution. Basically, we have a hash map which stores the frequency of each element. And now for every number within the given limit up to 10 power 5, we're checking how many operations we need, uh, how many operations we need to perform, uh, to make everything between that number minus k to that number plus k, that number. And after that, we take the minimum of those two, either operations required or maximum number of operations that are given to us, and we add that to the count, which is the frequency of the current element. Yeah, not my best job today, but thank you for watching.